Assalam Alaikum friend, welcome back. Today we will learn the Simatic Manager introduction, and I will create a simple project with giving you overview of the project environment and how can you select the hardware and how to design make a logic in Simatic Manager. I have Simatic Manager version 5.7 service pack with 2 in Windows 10. Okay, so let it open. Now the first time when you Simatic Manager open, I will give you the link for this software in description, so you can download from the link. Okay, so let's start. This is the front window when you open the Simatic Manager. Here we have a tool, sub tools, files, PLC. We will discuss one by one later on this video series. Okay, so let's say if I start from this scratch, I go to file and select new project wizard. In this option, the software will guide you step by steps what hardware to select and what language you want to use. Okay, so this is very basic. Let's say I click it. Now introduction page, software give you some information about it, and if you check this page, this tick mark, every time you open the software will take you the wizard options. Okay, let's say I click next. Okay, now here software asks you what CPU you want to use. Here is a list of a CPU which is available in Simatic Manager. So from here you have to select any CPU. No matter if you select here, later on you can change your CPU. I will select this one. Let's say for example CPU 312, and this is the order number of the CPU. After that I will change it. Okay, and I will explain more thing about that. This is CPU name. You can either put it same as, or you can, if you want, you can rename it. This is the MPI address of a CPU. Okay, and the by default OB1 is created. Cyclist execution, this is organization block OB1. There are many OBs, but this is the most important OB is OB1. I will discuss later about this OB in this video. Okay, let's say click next. Now see that by default it is compulsory OB1, so it is by default OB1 already checked. But if you want to use another OB, you can select from here. Different OBs for a different purpose. Let's say time of delay interrupt, we have OB from OB10 to OB17. We have a 7 interrupt for time of delay. Then after OB20 to 23, we have a total 4 OBs for a time delay interrupt. Then and so on, we have a different OBs. If you want to use, we can use. I will use some of them in later in order to show you the uses of OBs. Okay, now software wizard asks you in what language you want to program your OBs. Like we have a 3 option: STL, and the second is ladder, and third is FBD, function block diagram, ladder logic, and statement list. So I select the ladder. Okay, you can select any 3 of them, whichever you want. Then click next. Now project name, here asks you the project name. You can write, no problem, anything what you want. Let's say I write test 1. Okay. Okay, now finish. Now here you see the hierarchy. This is my project name test. Under the project test, I have selected the CPU from the 300. CPU name is CPU 312, and this is the S7 program hierarchy, whereas we have a source file and the block. All the OBs and FCs you find under the blocks. Okay, so here you can make it like this. Okay, now after that I create one. Let me show you the hardware setting. Okay, if you go to hardware, and from this window you can double click the hardware. First I'll select what CPU exactly I want, and how many input module and how many output module I want. I have to first define it here. Okay, see here it is CPU 312 as I selected here. In the start it is showing here. In the right window we have a different tools from where we can select what CPU we want. Either we want CPU 300, 400, or any other devices which will be connect on the DP, Profibus, PA, Profinet IO. So let's say I go to 300 as Simatic 300 and I want to change this CPU. Okay, I go to Simatic 300 and in 300 we have a different C7, CP, CPU, FM, gateway, IM, PS, rack, S7, SM300. So first I go to CPU. Okay, from the CPU we have a list of the CPU which I want to use, different CPU for different applications. So let's say if I select a CPU 315 2PN DP, and then here I select, let's say this one. Okay, if I double click, if I just clicking, you see the software left side showing the green highlighted, means that in each slot is dedicated for different module. Let's say slot 1 is dedicated for the power supply, slot 2 is dedicated for the CPU, and slot 3 is dedicated for the interface module, and from slot 4 to slot 11 you can use any IO modules. Okay, input modules or output modules or any special modules you can use. So when I click this one, it's saying you that the green highlighted space is dedicated. Let's say I just click it, see, asking me, do you want to replace? I said okay. Now because this CPU has the Profinet port, let's say here, if you see here, CPU 315-2PN, it has two Profinet port and also the DP port. So Profinet port is asking me the IP address. Let's assume I change it to default. I do not change. Let's say I just click OK. Okay, now the CPU is changed, and say here is showing that it has one MPI port and one Profinet IO. The MPI address is by default is 2. You can change it any from 0 to 31, means total 32 MPI devices can be connected with this CPU. Okay, now you have selected. Okay, the most important thing about the downside here, if you check this one, what is telling you, it's telling about that this is the order number of the CPU, this is the size of work memory, 128 kilobits work memory, 0.1 millisecond per thousand instruction. Actually this is the main things by which CPU is considered as a fast or slow. 1000 instruction per 0.1 millisecond per thousand instruction means that this CPU can perform 1000 instruction in 0.1 millisecond. Different CPU have a different time, cycle time. If any CPU has this time is greater, means that it is slow as compared to this CPU. Means that if a CPU have a longer instruction time, means that it is slow. If the CPU instruction time is less, means that it is fast. Let's say I give you an example. I select another, see here it is 0.1 millisecond. If I select this one, it is also the same. Now see, this is 0.6 millisecond per thousand instruction. 1000 instruction is made standard to check the speed. Let's say I have fixed at the how many time the CPU take to process the 1000 instruction. Now this CPU 313, this takes 0.6 millisecond to execute the 1000 instruction, means that it take longer time, means that this CPU is slower than the my CPU which I selected, which was this one. It takes 0.1 millisecond. It take less time to execute 1000 instruction. Okay, now again I telling you the Profinet connection, S7 communication, loadable, FBFCs, Profinet IO controller, all the basic information about the CPU it's showing here. Okay, now now after that the slot 3 is dedicated for the interface module. I don't want to use interface module, I just want to use single module, my SM series. So I take slot number 4, sorry, from here let's say I take this one. It depends on you, either you want to take digital input and an output on the same module, or you want to use separate digital input module or digital output module from here. It depends on you. Just to make you understand, I just select this one. You see, when I select, it's the right side window from all the window, it select the green highlighted space, means that this module can only be used on the slot number 4 to slot number 11. Okay, see, you observe slot number 3 is it did not select the slot number 3, means that you cannot add single module on slot number 3. Let's say I just double click, it automatically added a slot number 4. This is the digital input and output module, means that single module we have a digital input module and digital output module. And how many input we have? We have single 16 digital input and 16 digital output. Each one is 24 volt DC and the rating is 0.5 ampere. And what is the address? Address start for digital input 0 to 1, means 0 0.0 to 0.78, and then 1.0 to 1.78, 8816, and the same is from the same for the output address 0.0 to 0.7 and 1.0 to 1.7. Might be some students confused here that the address is same. How is possible? Yes, the input and output address can be same, but not the same inputs, means that if you use another input module, that input module address should not be same like this previous one. Okay, and the same the output. Okay, so we have a 16 digital input and 16 digital output module. Now I just compile it and I just close it. Okay, now I go to view and tell him to show all level from the block. This is OB1. First I just take the one FC. Let's say I go to my insert FB and then function. I say this is FC1. I can give any name. Let's say I tell him to logic gate. Okay, logic gate, and I tell him I want to program in the ladder, and just click OK. Okay, now my one FC is created. Now I double click on the FC. Now I am in FC1. Okay, ladder, the name of the FC is logic gate. Here is we have all the tools which we can use in the programming language. These all the different bits logic, comparator, converter, counter. We will learn one by one. Just now I just want to create one AND logic. I go to bit logic. If this window is not visible to you, you can, let's say it's not visible like this, so you can go to view and select overviews. It will be there. Okay, now I just take this one, click, double click, and one time this one, double click. Now 2 input, 1 output. Now just name it. I give I 0.01, I 0.0, I 0.1, and Q 0.0. Okay, now most important thing, that in the Simatic Manager all the input is defined by I and output is defined by Q. Different CPU, different PLC, not CPU, different another PLC from the another brand have a different symbol for input and output. Just I wanna give example that if you are using the Mitshubishi PLC, it has symbol X for input and Y for output. In the same way, different brand use different notification. But the Siemens, all the CPU of Siemens, either it is S7 200, 300, 400, anyone, it use for input as a I and output as a Q. Digital input, not for analog. Analog is also for IA or IW, will learn in the later. but the digital input I and Q. Okay, now I want to name it. Name it means I want to give the symbolic name for that. For that I will just right click and go to edit symbol. Okay, when I click the address symbol, it will give me all the input address which is used in the network number 1. Okay, so for that let's say I 0.0 I name it, let's say input 1. I can give the comments. Let's say I skip the comments. I just say input 2 and this is output. Okay, now okay, now you can see that each input have a different name, so it is good way to give this a symbolic name so that you can understand. I can give this name as a sensor 1, sensor 2, switch 1, switch 2, whatever the name, it depends on the your logic which we are using with the plant. Okay, now I just click click your save. Okay, and now close. Now the most important thing that the OB1, as you create the FC, FB, anything else which have the input and output to take the input from the hardware and give the command to hardware to on or off, all that FCs must be called in the OB1. Actually OB1 is the organization block. It is a basic block. Most important that it actually interact between your computer to the hardware, make a interface link between the hardware and software. So it will not work unless I call this FC1 in OB1. So how will I do that? I will just open OB1, and from the OB1 in the network, just say I have right now only one FC1. So see, we'll go to FC block. Here you see this logic gate FC1. I just will double click, it will be called here, this FC called here. Now I just save and then take out. Now I want to simulate it, I want to check it, I want to simulation. So how will you do that? I will just open this simulation on and off window. Okay, from here this is IB1, this is QB. Okay, this is 1 byte of input from 0 to 7 and output is 0 to 7. This is enough for me to check this logic. Okay, is enough to check my this logic. Okay, now I just put it into the run P mode. Now CPU is in the run mode. Now if I save it and download, okay, and now this is the monitor on and off. Now it is not being monitored. Why? Because I have to download FB1 also. Okay, it's telling me the FB1 already executed. Yes, all. Okay, okay, what happened from my this one? Okay, I have downloaded whole project in this CPU. Keep in mind, when will be downloading, this simulator will be on, its CPU should be in the run mode. Okay, now I just save it and online, make it online. Now see, it is now online monitoring. It is just like same as you are interacting with the real CPU. Where is my simulator? Okay, now check it here. This is my 0.01 in this memory. In this simulator, this is 0.0, 0.01 to 0.7. okay, 1 byte I just take it. When I click this one 0.0, you observe the behavior of the hair. See, this is high. Now when I click the 0.1, the output should be high also here and also here. See, the output is high, and also this in the simulator output 0.1 is high. So This way you can simulate, you can make any logic and simulate in this simulator of the Simatic Manager. This is very good tool. So I hope you'd like this video. I will continue this video session next time. I will take the same project and add more logics, more comparator, converter, all the things we learn on the same project. So it's better you start from the here and keep going as I will upload the video in the next time. Thank you for watching. If you like, please like and subscribe this video and share among your friends. Thank you and Allah Hafiz.